Okay, in the 76 one, again you have such an easing problem in which the statement 1 is this and statement 2 is this. Statement 2 is obviously correct, no need to check it up. This is one of the property of definite integral. If we utilize that fact in that integral what is given to you, you can clearly check up the a plus b is 90. So if I consider that as pi by 6 to pi by 3, and if I take in place of x 90 minus x, this is going to be cot x. If I take it as 1 by root of tan x and take LCM, you end up getting the value of the same integral I as in this way. This I and that I, if you observe, they have the same limit. So if I add them up and clearly check up, that integral becomes this only, which is going to give you the value of I as pi by 12, not pi by 6. So this statement is a false statement, implies then we have the fourth option correct. Okay, in this problem we have this information that a circle which passes through foci of this particular ellipse having center at 0, 3. So effectively, and then on that basis we have to find out the equation of that circle. Obviously equation of that circle we can take it in this manner. So only unknown in that is r square. For that case, out of the two foci, even if we figure out one of them, we can figure out the value of r square and hence that circle. So for this case, first you need to obviously compute E, and E square, if you observe, that is certainly going to be 1 minus that b square by a square, which is 9 by 16, implies this much. So if I consider the coordinate of the two foci, which is nothing else but then plus minus root 70, out of which even if you take one of them, you'll find that this r square is going to be 16. For that case, then the equation of circle is this, which is what is the first option given in that problem. Okay, in the 78th one, you have this information that a multiple choice examination has got 5 questions, and for each and every question you have 3 options, out of which only one is correct. Then we need to figure out the probability that a student will get 4 or more correct answers just by guessing. Since we have 3 options, one thing you can clearly check up, that if someone is guessing that problem and is going to get correct answer for it, if someone is guessing that question and since we have 3 options, obviously marking it correct probability is going to be 1/3, but if the answer is incorrect, then the probability of marking it incorrect is 2/3. What we need to manage in this case is that a student will get 4 or more number of correct answers. So you have to consider 2 situations. Either he has got exactly 4 correct answers or he has got all 5 correct. For this case, which 4 makes a difference? So we need to select those 4 questions out of 5, which he is going to attempt it on the guesswork and he has got it correctly. So for that case, since he is guessing it 4 times correctly, 1 time incorrectly, so that probability is going to be this. And if he is guessing all the problem correctly, then the probability of that case is going to be this much only, which you can clearly check up is going to match with 5c4 is 5 and this is 1. So you have 10 and that 1, 11 by 3 to the power 5, which is the third option in that paper. In the 79th one, the information given to you as for a triangle, three midpoints of the 3 sides are given to you, and on that basis you have to find out the abscissa of its in-center. For that case, what we need to do is, if I consider the coordinates of this point as x1, y1, this one as x2, y2, x3, y3, we can clearly have a connection between x1, y1, x2, y2, x3, y3, etc. you can check up you have sufficient information like this. On the basis of these many 6 equations, you can figure out all those. Once you figure out them, you know all these coordinates. Once you know all these coordinates, we have a formula by the perimeter of that triangle as the abscissa of the incenter. If you compute this set of x1, x2, x3, we are actually, if you observe, we are not even bothered about y1, y2, y3s. So we need to solve it for 3 variables only. If you figure out that somehow, this quantity is to simplify to 2 minus root 2, which is the second option. Okay, in this case the problem was in this expansion, the binomial expansion of this, we need to figure out the term independent from x. Obviously, before you go in for binomial expansion, we need to simplify this matter. If I consider this as x to the power 1/3 cube, this is a cube plus b cube, this is what is a square, b square and ab. If I simplify this matter, we'll end up getting x to the power 1/3 plus 1. If I take out root x out of this place and then treat it as a square minus b square of root x and 1, you will find that this quantity is then going to simplify to which you can check up, it is simplifying to a general term of this expansion would be all you need to do is then you have to compute the power of x, the total power of x, that is this much and minus half r, and make it 0. You will find that r, by this got it as r minus 2 equal to 0, which you can check, it is simplifying to r is 4, and if r is 4, the required coefficient what we are looking at, or the term which you are looking at, is 10c4, which is what is the third option given in the problem. In the 81st one, we have this information that we have two curves, one is a parabolic one and the other one is a straight line. What you need to do is you have to figure out the area enclosed by this curve, this line and the x-axis in first quadrant. If you observe, y equal to root x is going to be of this type. This particular line is going to cut x-axis at 3, 0 and y-axis at minus 3 by 2 and 0 comma minus 3 by 2. This is what is the area we are interested in, that is in the first quadrant. For this particular point, you need to obviously solve this pair of equations. So if you put root x in place of y here, you can check up, if I take root x as t, this is 2t minus t square plus 3 which is simplifying to this, and the roots for this the acceptable, we know that this t is positive, so rejecting the negative value out of this, we end up getting t as 3, where t, if you recall, was root x, so x is 9, for this particular case. Obviously y is 310. To find out this particular area, I can check up, we need to break up this area into multiple parts. But if I consider this complete area and we subtract this right angle triangle, that would be much easier. So for this complete area, all you need to do is you need to start off with x equal to 0 to x equal to 9. Then to the upper curve, that is root x, minus the lower straight line, which is this is what is going to be the complete area, out of which we need to subtract the area of this right angle triangle, which can be easily computed as half 3 and 3 by 2, simplifying to 9 by 4. So if you simplify this whole matter, you will end up getting the required area. Okay, in the 82nd one, this Tn, it is given the problem that Tn denotes the total number of triangles formed in a regular polygon of n side, and then this information is given and we need to compute something about n such that this statement work out. First of all, if you look at number of triangles in case of polygon, and if we select randomly any 3 vertex out of n, we'll end up getting a triangle. You won't get a situation wherein 3 vertices of a regular polygon are collinear. So this is what is Tn. On that basis, you can check up then this equation simplify to this. Clearly n equal to 5 out of those options is satisfying. So the second option is correct in that problem. Okay, in the 83rd one, we have these two information given that mod z is 1 and argument of z is theta, and then we need to figure out this value. In this case, one way is the mathematical approach, another one is the geometrical one. I am proceeding with the geometrical one. Since z is mod of z is 1 and one complex number is also involved in this, I am considering z as a point on a unit circle. Obviously 1 is going to lie at this place. Z bar is going to be the image of that somewhere on this circle itself. 1 I am utilizing just because that is involved in this. And using 1 and z, if you form a parallelogram, rather it's not going to be a parallelogram, it's going to be a rhombus further, because this length and this length are same. So if I consider the diagonal, this is what is going to be 1 plus z. This is going to be the angular bisector also. Since this complete angle is theta, this is going to be theta by 2. And in a similar way, if I proceed on the other side of the x-axis, you will end up getting 1 plus z bar somewhere here, which is also going to make theta by 2 angles. We are actually then looking at, if you observe, we are looking at this complete angle. This thing you can say it is nothing else but this complete angle, which is what is theta by 2 and minus of theta by 2, adding up to complete angle as theta, which is what is the third option given in that problem. Okay, in the 84th one, this is the kind of setup we have. We are dealing with a trapezium ABCD with this information that AB and CD are parallel and further BC is perpendicular to CD, and these are the data given, and we are looking at this as a function of P, Q and theta. If you look at this complete information, since we are looking at this AB length, I am taking that as x, that is obviously going to be x here. This part is then going to be equal to Q minus x, and we have this particular angle as theta. Suppose if I am assuming that this particular angle is alpha and this complete angle is beta, and say I am looking at tan of beta value in this right angle triangle. In the smaller one, if you consider tan of beta, that is going to be P by Q minus x, and in this right angle triangle, that is DBC, if I consider tan of alpha, it is going to be P by Q. We know this fact that beta minus of alpha is going to be equal to theta, and since we have a whole lot of tangents involved here, if I take tan on both the sides, we'll end up getting the value of x, as in tan beta minus tan of alpha by 1 plus tan beta tan alpha would be equal to tan of theta. If you simplify this whole matter after substituting these values, we can clearly check up in this only x is the unknown, rest all other quantities are known to you. If you figure out the value of x, you will find that the value is going to match with the option 1 given in that problem. Okay, in the 85th one, this is the information given that the matrix A is this much, which is 3 by 3 matrix, which is adjoint of A, wherein it is given that determinant of A is 4. On that basis, you have to find out this alpha. We have this information that determinant of adjoint of A has to be equal to determinant of that matrix A to the power its order minus 1, which is in this case 3 minus 1. Since we have this information, we can write it as 16. If you simplify the determinant value of this, you will end up getting alpha. If you substitute the determinant value of that here, you will end up getting alpha as 11, which is what is, I guess it's the second option. Okay, in the 86th problem, there is a curve given, and what you need to do is that you have to find out intercept on x-axis made by tangent to this curve, which are parallel to y equal to 2x. Then obviously slope of this line is 2. All you need to do is that for this case you have to calculate dy by dx, and that you have to equate it with 2. For that case, if you consider dy by dx of this for positive x, y is going to be 0 to x, this is going to be t dt only, and if you simplify the whole matter, you'll end up getting this. But if I take x negative, you can clearly check out it's going to be negative of x square by 2. This is how that function is defined. And for this case, derivative in the two cases, you can check out it's x or minus x. So x or minus x, if I equate it to, we have got abscissa of the point of tangency as plus minus 2, implies then the equation of tangents for x equal to 2, it is going to be 2, slope is 2, this is one of the tangent, and the other one, if I take x as minus 2, it's going to be minus 2, the slope but is still going to be 2, and abscissa is minus 2. In this case as well as in this case, we are looking at x-intercept made by this. If you observe in the two cases, you end up getting x equal to 1 or minus 1, which is what is the first option given in that problem. Okay, in 87 one is again an assessment reasoning problem. We have one circle and one parabola. In the statement 1, it is being told that this line is the common tangent, and the second one, as far as this parabola is concerned, it's being told that this is a tangent where m is not equal to 0 to this parabola, and if this same line is a tangent to this circle also, then it will have this kind of relationship in m. That's what you have to check. See, in this case, the way this second statement is given, this is perfectly fine that this kind of equation is going to be a tangent to that for every m. If this line is tangent to this circle, then the perpendicular distance of origin, that is the center of the circle, from this line should be equal to the radius. If we utilize that fact, we end up getting this is what is the perpendicular distance of origin from this line, and that should be equal to the radius of this circle, which is this much. If you square up this and take m square as t, you can clearly check up you are getting this equation effectively in m. I've got this equation. Further, out of this, you can clearly check it's a quadratic in m square. The roots are, one is 1, the other one is minus 2. Obviously this is not allowed. M equal to plus minus 1 we end up getting. If I take m as 1, you can check this line matches with this line, so first statement is a correct statement, but this quadratic what is given in that, it's not matching with it, so this is a false statement. So third option is the correct answer for that problem. Okay, in the 88th one, this is the function given and you have to figure out its dy by dx at x equal to 1. Since tan inverse x is given, suppose I am assuming that this is an angle theta. So obviously x is then tan of theta. If x is tan of theta, this becomes sec theta. So y in terms of that theta, you can clearly check up, it's going to be this much. The derivative of this actually we are looking at when x is 1. Derivative of this would be this much. If we substitute x equal to 1, you can clearly check this becomes 1 by root 2. I guess this is the second option of that problem. Okay, in the 89th one, this is the expression you have which you need to simplify. One option is that you take some suitable angle A and match with one of the option. Alternatively, if we convert all of them into tan of A and I'm taking tan of A as t, you can check up, this becomes t square by t minus 1 and this quantity, so if we take LCM, we are going to have t cube negative 1. So t minus 1 factor is certainly going to cancel off because tan A can't be 1 in this. If you cancel it off, you are going to be left with t square plus t plus 1 by t, which is nothing else but cot A plus tan A plus 1. And if we convert this and this into sine and cos, and if you simplify the matter, you can check up this quantity is going to give you 1 by sine A cos A, which is this is what is the second option of the problem. Okay, in the last problem, that is the 90th one, it is given that if in a class all students are performed miserably in maths, then the concerned teacher has given 10 marks to all of them, the grace mark to all of them. Then what are the quantities are not going to get affected by this? The options were mean, median, mode and the variance. In that case, if you are aware of the formula, you can clearly check up. It's variance only which can't get affected by shifting the origin. The origin is being shifted from 0, 0 to 10, 0 in this case because of its formula itself. Nothing to calculate in that. You can check up one thing. By the formula of the variance, you can check if you shift the origin, this quantity won't affect that expression because since we are shifting the origin, this expression is not going to get affected. Except this, all other quantities are going to get affected. So this is going to be the option, the correct option. That is what is the fourth option of that problem.